The next question is, an atom has non-degenerate ground state and a doubly degenerate excited state. The energy difference between the two states is epsilon. The specific heat at very low temperature is given by. So we have to know what is the specific heat at lower temperature. So for that purpose, we got to draw the first diagram. So it is doubly degenerated. Degeneracy of the excited state is 2. The energy difference between the ground state is degeneracy is 1. It's non-degenerate state. So the energy difference is epsilon. You can take on this is zero energy. This is higher energy. The difference is epsilon. So from the partition function, you can write in written as sum over I, the degeneracy of each state, e to the power beta, the energy of the each state. So sum over this energy, the I is running indices. First ground state you can take as degeneracy is 1, energy is 0. Here the axis y axis is energy axis. So you can take on the ground state is degeneracy is 1 minus beta, energy is 0, plus excited degeneracy is 2, energy is epsilon minus beta E. So partition function is 1 plus 2 e to the power minus beta E. Now we go to calculate the average energy of the particle in these configurations. From the partition function, we know the average energy should be equal to dou by dou beta ln of the partition functions. You got to know these relations. From the StatMech, use this formula minus dou by dou beta ln of 1 plus 2 e to the power minus beta E minus dou by dou beta. If you are taking derivative of logarithmic function, it will give 1 divided by that argument into, you have to now differentiate the argument. 1 if you are differentiating it will give 0, plus if you are differentiating exponential it will give exponential, then you got to differentiate the exponential argument. So if you are differentiating exponential argument, it will give minus epsilon. Already 1 minus here, 1 minus, so plus 2 e to the power minus beta E divided by 1 plus 2 e to the power minus beta E. Next we want to find they are asking specific heat at very low temperature. This calculation now it's simple. Specific heat at low temperature. We can calculate the specific heat first, then we can come to the lower temperature. Configuration, what is specific heat? Specific heat is nothing but dou E by dou T, the average energy of the derivative of average energy with respect to the temperature. Just we can do the derivative of these functions. We can keep that numerator as it is, e to the power minus beta E, divide the 1 by 1 plus 2 e to the power beta E. If you are dividing this one, it will give minus of 1 divided by 1 plus e to the power minus beta E whole square. Then differentiate again this one. So if you are differentiating, 0 plus e to the power minus beta E dou by dou beta T. So modify the differentiation because all the arguments, all the functions, average energy in terms of beta. So modify the specific heat in terms of beta. The derivative is in terms of beta. I can do what dou u by dou t. What we can written as dou t as 1 by t. Here I can write in as t. If you are differentiating 1 by t, it is 1 by t square t square will go, so I can call it as 1 by 2 t square here into kb. Now it will satisfy minus 1 by kb t square, so dou by dou kbt. If you are differentiating, it will give us exactly minus 1 by t square, so t square will get cancelled, kb will get cancelled, dou by dou t it will come. So we can modify the specific heat minus 1 by kbt square dou average energy divided by dou beta. Now we can take the differentiation minus 1 by kbt square dou by dou beta, that average energy is nothing but 2 e to the power minus beta e or beta epsilon. We both are represent the energy of the state. Now we can take the differentiation, so cv is equal to minus 1 by kbt square. For differentiating up around, keep the lower 1 by 1 plus e to the power minus beta e, so keep this term lower one. For differentiating upper one, 2 e to the power minus beta e minus e, plus keep the upper one as it is. Differentiating lower one will give e to the power minus beta e whole square minus it will come front side. Then if you are differentiating again, it will come minus beta e into minus. So minus 1 by kbt square take the common denominator as 1 plus e to the power minus beta e whole square divided by, if you are multiplying this to minus 2 e to the power minus beta e into 1 plus e to the power minus beta e minus into minus plus e to the power 2 e to the power minus 2 beta e. Now we got to simplify these expressions. So in the next page, I'm erasing the question. I'm taking the previous page results. So this is our result. Finally, we got minus 1 by kbt square minus 2 epsilon e to the power minus beta e into 1 plus e to the power minus beta e plus 2 e to the power minus 2 beta e divided by this whole square. I'm writing the same expression here. You can check. So this should be equal to minus 1 by kbt square multiply inside the first term minus 2 epsilon e to the power minus beta e minus 2 epsilon e to the power minus 2 beta e plus 2 epsilon e to the power minus 2 beta e divided by 1 plus e to the power minus beta e whole square equal to minus 1 by kbt square. We can cancel these two, so minus into minus plus 2 epsilon we can take out e to the power minus beta e divided by 1 plus e to the power minus beta e whole square. Here they are given the one condition at lower temperature limit. That means beta e much greater than 1, because beta is equal to 1 by kbt. At lower temperature approaching 0, beta is infinity. That size is much greater than 1. Apply this condition here. So 2 epsilon divided by kbt square. If it is much greater than 1, this value goes to infinity. or also you can take an if t approaching 0, this is invalid. That means it goes to approximately 0. So e to the power beta e at lower temperature limit. So we can convert it as a 2 epsilon or kb multiplied with kb. So kb square t square e to the power minus beta e. You can return as 2 kb epsilon 1 by k square beta t square is nothing but beta square e to the power minus beta e. So given option in the question paper is, where is the given options? Specific it's in the question paper. So the given option it's the third options, beta e whole square e to the power minus beta e kb. We are missing one e, maybe some calculation mistake. So option is 3. Here the option, given option is 3.